Hello everyone. I welcome you all to my lecture on kinematics of particles. In this chapter, we are going to do the motion analysis of particles without considering the force. There are two types of translatory motions are there. The first one is rectilinear motion. Okay. In the rectilinear motion, the particle moves along a straight line. The movement of a car in a straight road is the typical example for rectilinear motion. The second type of motion is curvilinear motion. Curvilinear motion occurs when a particle moves along a curved path. The motion of a missile is the typical example for curvilinear motion. We will start with rectilinear motion. So, rectilinear motion is the motion of a particle in a straight line. So, here the two balls and two rollers are moving in a straight line. That is why it is considered as rectilinear motion. You can see the path tracked by the rollers and the balls. It is a straight line. That is why it is called as rectilinear motion. The movement of a car in a straight road and the movement of a person in a running track is the examples for rectilinear motion. In rectilinear motion, the location of particle is specified by the term position. So here the particle is located at a distance of s from the origin. So generally the position is measured from the origin. In most of the cases the origin will be 0, 0. So here s is the position of the particle. So here the s is positive, that is why the particle is on the right side. If it is negative, then the particle will be at the left side. The example for position is the car is placed at a distance of s from the electric pole. So here the s is the position of the car, and position means it is the distance. So the distance is generally measured in meter. So also the position is also measured in meter. Then the displacement. So here the particle moves from the position s to s dash. So the difference between s dash and s is delta s. So that is the change in position. So this change in position is called as displacement. Okay, so displacement of the particle is defined as the change in its position. In this example, the car is located at the distance s. If the car is moved to s dash, then the difference between s dash and s is the displacement. So the unit for displacement is also meter. Next is velocity. The velocity of an object is the rate of change of its position with respect to time. So here the object is moving from its first position to the final position. So to move this distance delta s in a period of time, it has some velocity. If the velocity is high, then the particle will move in a less time. If the velocity is low, then the particle will move in a very long time. So here car is moving with some velocity from s to s dash. So mostly in automobiles we will specify the speed by kilometer per hour. For example, consider the car is moving at a speed of 30 kilometer per hour. Okay, the meaning for 30 kilometer per hour is if the car is operated at a constant velocity, then this will cover a distance of 30 kilometer in 1 hour. So that is the meaning for 30 kilometer per hour. Next is acceleration. So acceleration is the rate of change of velocity with respect to time. So at the initial position, the particle is having a velocity of v, and at the final position, the particle is having a velocity of u. So in between these two positions, its velocity is changed. So we can consider that its velocity increases. So that rate of change of velocity is called as acceleration. So if the acceleration is high, then the change in velocity or increase in velocity will be high. If the acceleration is low, then the increase in velocity will be slow. So A is equal to dv by dt. In automobiles, if we apply throttle, then we are increasing the velocity. For example, we are increasing the velocity from 10 km per hour to 40 km per hour. In the same time, if you apply brake, then we are reducing the speed from 40 km per hour to 0 km per hour. So that is the difference between acceleration and retardation. So with this example, you will get a clear idea about acceleration and velocity. So initially, a 1 meter per second square acceleration is applied. So the velocity is increasing from 0 to 1. I am continuously applying the acceleration. So the velocity is increased to 2. Further, I am applying the acceleration. The velocity is increased to 3. Further, it is increased to 4. 5, and now I am applying the brake, so its velocity becomes 0. So that is retardation. There are two types of rectilinear motions are there. The first one is with constant acceleration. So with constant acceleration, the velocity changes uniformly with respect to time. So from this graph you can see that the velocity changes uniformly with respect to time. So that is uniform acceleration. Then the next one is varying acceleration. So in the varying acceleration, the velocity will not vary uniformly with respect to time. Finally, the equation of motions. To solve the problems in uniform acceleration, we have the three equations. One is v is equal to u plus at, then the second one is s is equal to ut plus half at square, and the third one is v square is equal to u square plus 2as. If your system is with uniform acceleration, then we can use these three relations to find out its position, displacement, velocity or acceleration. So here v is the final velocity, u is the initial velocity, s is the displacement, a is acceleration, and t is the time taken. Okay, so with these three equations, we can move on to the problems. In my next lecture, I'll teach you how to solve the problems in uniform acceleration. Thank you.